Today we're going to look at doing some gas laws. Okay, our first question said the volume of a sample of gas is 650 milliliters at a pressure of 1.6 atmosphere. Assume that the temperature is held constant. A, what is the volume of the sample at a pressure of 2 atmospheres? B, what is the pressure when the volume is 1,000 milliliters? And C, what is the pressure of the sample if 500 milliliters? Okay, when you're looking at this type of problem, first thing, all these things feed off of the ideal gas law equation. All of these gas law problems are somehow related to the gas law problem. So in this particular instance, we are told that temperature is held constant. So if temperature is held constant, then this NR is also considered a constant, which allows us to have PV is equal to K, and if PV is equal to K, that means that we have P1 V1, which is equal to P2 V2, and whenever we have this here particular relationship, we know that we have Boyle's law. So when we're reading this equation, we need to do a couple of things. Label the equation as we go along. We said the volume of a gas is 650 milliliters. So that V1 is equal to 650 milliliters. At a pressure of 1.6 atmospheres. So my P1 is equal to 1.60 atm. Assume that the temperature is held constant. What is the volume? So V2 is what we're looking for, of a sample at a pressure of 2 P2 is equal to 2 atmospheres. So normal relationship, P1 V1 is equal to P2 V2. I simply plug the information back into the equation, or since I'm solving for V2, I can solve for V2, which would tell me that V2 is equal to P1 V1 over P2, and then substitute the quantities back into the equation, which P1 is equal to 1.6 atmosphere times V2, which is equal to 600, I'm not V1, which is equal to 650 milliliters divided by my P2, which is 2 atmospheres. And when I do that, I would get 520 milliliters as my calculation, which, if we look at this, we want to know if this makes sense. We know that pressure is inversely proportional to volume. So as I apply pressure, the volume goes down. So if I have 1.6 atmosphere and I go to 2 atmosphere, indeed I would expect for this 650 milliliters to decrease, which is exactly what I see, 520 milliliters. So the answer makes sense. So that's important. You want to make sure that your answer makes sense. Okay, let's look at part 2 of this equation. It says, what is the pressure when the volume is 1,000 milliliters? So again, if it's 1,000 milliliters, we want to have our P1, which is equal to 1.6 atmospheres. We want our V1, which is equal to 650 milliliters. Our P2 is in question now. It says, what is the pressure when our volume 2 is equal to 1,000 milliliters? So again, we have P1 V1 is equal to P2 V2. If we solve the equation for P2, we're going to have P1 V1 divided by V2, which would be equal to 1.6 times 650 divided by 1,000, which would give us an answer of 1.04 atmospheres. So again, let's see if our answer makes sense. We're saying that pressure is inversely proportional to volume. Pressure is inversely proportional to volume. If I have 1,000 milliliters, it says what is the pressure when the volume is 1,000 milliliters. So my 1,000 milliliters is increasing. My volume 2 is going to 1,000 to 650. So if I have 1 atmosphere, 1.6 atmosphere is what I start with, and I increase my volume, which means that my pressure should decrease. And that's exactly what we see here. We started off with 1.6 ATM, and our volume increased, which means that this pressure here should decrease. So that's exactly what we see. Let's look at our next problem. This part C of this equation. Says what is the pressure of a sample at 500 milliliters? So again, we write down what we have. We have our pressure 1 is equal to 1.6 atmospheres. We have our P2, which is in question. We have our volume 1, which is equal to 650 milliliters. And we're told that our V2 is equal to 500 milliliters. So if we solve this equation, we would have P1 V1 is equal to P2 V2. Solving for P2, we would have P1 over V1 divided by P2. And we substitute the values back into the equation. We'll have 1.6 times 650 divided by 500, which means that pressure 2 should be 2.08 atmospheres. And again, does this make sense? If I have 1 atmosphere, I have 650 milliliters I'm starting with. If I'm decreasing my volume, that should mean that my pressure has increased, which is exactly what I see in this equation.